Welcome back into the second part of the lab. So we've shown you the two ways to actually create a VLAN on a 2960 switch. We'll now show you some of the VLAN switch port configuration commands you can use. Now, as we mentioned, a VLAN is a layer 2 construct. However, you can have your switch route between VLANs if you have a layer 3 switch. None of the switches I have in this topology are layer 3 switches. However, you can still configure the commands on the 2950 and 2960. You just can't route any layer 3 traffic between them. So for example, let's go into config mode, and spacing is important. Let's try that again. We can create a VLAN subinterface. In the switching parlance, this is called an SVI, or a switch virtual interface. And the name of the interface corresponds to the VLAN number that it represents. In this case, we will do interface VLAN 30. You'll notice that shortly after we go into interface configuration mode for this VLAN SVI, that it brings the line protocol up because the VLAN is active on this switch. It has ports configured in the VLAN, and so that means it can be active. Now we can look at some of the commands we can use on this particular guy. Now these commands are the same types of commands you'd see on a physical interface. For example, you can set CDP options, as you see here. You can set IP options, so you can actually set an IP address. And again, if you have a layer 2 switch like this 2960, you can only have one VLAN SVI with an IP address active at any given time because it will not allow you to do layer 3 switching. But this is also the place where you can set an interface description, and that's generally what's done under these VLAN SVI. So we'll do description, we'll do DMZ VLAN. And you'll notice that unlike the VLAN name, you can actually use spaces in the interface configuration because, again, this is not a VLAN configuration, not VLAN specific. So now if we were to go out here and we were to do show IP interface brief, you see we have VLAN 1 and VLAN 30 as valid interfaces. I have my VLAN 1 interface admin down because that's how it comes up as default. But you'll notice that it appears like any other interface on the switch. In fact, there's my loopback 1 interface. It's got that IP address that I used for another course. So now that we've covered pretty much everything there is about the creation of VLANs, let's move on to VTP, or the VLAN trunking protocol. And this is where things can get interesting, in my opinion. So the first command we're going to use on this 2960 is we'll do show VTP status. And let's look at all the information that this particular command tells us. First off, it tells us the VTP version we're running. We're running VTP 1. We are capable of running VTP 2, but again, really the only difference between the two is that version 2 supports Token Ring, where version 1 does not, and since we're not running Token Ring, we'll just leave it at VTP 1. It tells us the configuration revision, and this is how many configuration revisions have been done to the VTP database since the VLAN.dat file was deleted on the local flash, or since the VTP domain name was changed. In our case, since I pretty much wiped the config on the switches, as far as VLANs are concerned, we only have 2 configurations done to this local VLAN database since we started our little lab here. We can support up to 64 VLANs locally. We have 7 VLANs configured. If you'll remember, we have those default VLANs for Token Ring and so on and so forth. VTP operating mode is server, so we are in server mode, but we have no domain name. So that means any other switches that receive our updates will simply ignore them because the VTP domain name is null, if you'll recall our little mini flowchart in the slideshow deck that we had a little earlier. We have disabled VTP pruning. We've not turned on the bit to run in version 2 mode, and you may think, well, why do we have that listed in 2 places? This here tells us if the bit is set from the VTP server to run in version 2 mode. This here tells us what version we're actually running. You may have some older switches in your environment that may not support VTP2, and so if you do show VTP status on those switches, it will tell you that it's running VTP1, but the VTP v2 mode bit is set. The next line tells us whether or not we're sending SNMP traps for VTP events. In this case, we're not, although if you run a particular network management system that can consume those traps, you may want to turn those on just so you can see what VTP is doing. It gives us the MD5 digest for the local VTP database, and I've never really had to use that other than to verify that it's the same on all of the switches. Configuration is last modified by, and it gives us the updater ID that last modified the configuration. and it gives us the date and time it was last modified. And I promise we haven't gone 20 years into the past, I just haven't set the correct date and time on these switches. It then tells us what our local updater ID is. And since we're running in VTP server mode with no domain name, you'll notice that the last modified by line is the same as our local updater ID because we were the last ones to modify our configuration. It tells us where it got that updater ID. It's loopback 1, which is the first layer 3 interface found, and that's why this loopback 1 interface is configured, because even though VTP is a layer 2 protocol, it still requires a layer 3 interface to use as its updater ID. And since most switches have a management IP on them, that's generally not a problem, except maybe in a lab, and I've never actually tried running VTP without any layer 3 addresses on there. So we'll carry on with our discussion of VLAN trunking protocol in the next video.